Hello third year, welcome to the second lesson of this week. Today we are going to be looking at the chemical formula of two element compounds. Our learning intention for today is to work out the chemical formula of two element compounds. Now, based on last lesson, you should be able to name a compound if you know the elements present in it and identify the elements present in a compound from its name. That's where we are starting off today. Now, hopefully by the end of the lesson, you will also be able to state what's called the valency of an element as the number of bonds it can form with other atoms. If we've had a really good lesson, you will also be able to tell us, or you will also be able to use the valency of an element to work out the formula of a compound. And I'm going to show you how to do that. Now, we are going to be working out the formula of ionic compounds and covalent compounds. And it's important that you know that when we are talking about ionic lattices, so our ionic compounds, the formula shows us the ratio of atoms. Now, in sodium chloride, the ratio of sodium to chlorine is 1:1. So the formula is NaCl. Number 1 does not show up in formula at all. So I'll say that again. In an ionic compound, its formula tells us the ratio of atoms in the compound. So in sodium chloride, for every 1 sodium ion, you have 1 chlorine atom. When we are talking about the formula of a covalent network, this shows us the ratio of atoms in the structure. Now remember, our covalent networks are massive structures composed of thousands and thousands of atoms held together by covalent bonds. So when we are talking about silicon dioxide, for example, its formula is SiO2. And that tells us that in a network of silicon dioxide, for every 1 silicon atom, you will have 2 oxygen atoms. So for our ionic compounds and our covalent network compounds, the formula is the ratio of ions or atoms in the structure. For our covalent molecular substances, it tells us the number of each type of atom in the molecule. So instead of being a ratio this time, the formula of covalent molecular substances tells us how many of each atom you have in a molecule. So for example, we have water, which is H2O. So in 1 molecule of water, you have 1 oxygen atom and 2 hydrogen atoms. So just to summarise that last slide, there's a lot of information on there. I spoke for quite a while. We can divide our compounds into ionic or covalent. Ionic compounds are made of metal and non-metal ions. The formula is the ratio of ions in your lattice structure. Now, covalent compounds are made of non-metal atoms. In a covalent network, the formula is the ratio of atoms in the network structure. And in covalent molecular compounds, the formula is the number of each type of atom in the molecule. What I would like you to do now is take the heading in your jotter to element formula and copy down this flowchart for me. So that brings us on to the topic of valency. Now, the valency of an element is how many bonds it can make. The valency is the same as the number of unpaired electrons in the outer energy level. So if you were to look at page 6 of your data booklet and find any element and look at the number of unpaired electrons in the outer energy level, that will tell you how many bonds that element can form. Now the following table here can be used to work out valency. So elements in group 1, so lithium, sodium, potassium and so on, they have 1 unpaired electron in their outer energy level and their valency is 1. Group 2, which is the group beginning with beryllium and magnesium, have 2 unpaired electrons in their outer energy level. Therefore, they can form 2 bonds. Their valency is 2. Group 3 has 3 unpaired electrons. It has a valency of 3. Group 4 has a valency of 4 as it has 4 unpaired electrons in its outer energy level. Now let me just explain this to you now, particularly for groups 3 and 4, this unpaired statement. It only makes sense if we think back to how we draw out electrons in our energy levels. So what I have here, let's just pretend we are drawing the outer energy level for carbon. Now carbon is in group 4 and it has 4 outer electrons. Now the way we draw these is we work our way around the clock. So we start at 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So it has 4 outer electrons and each of these 4 electrons sits on its own. They are unpaired. Moving on to group 5. It has 3 outer electrons. These are the elements. So moving on to group 5. Now group 5 has nitrogen at the top and that has 3 unpaired electrons. Its valency is 3. Group 6 has 2 unpaired electrons. Its valency is 2. Group 7 has 1 unpaired electron. Its valency is 1. Group 8 is our noble gases. They have a valency of 0. They have no unpaired electrons in their outer energy level. They are incredibly stable and unreactive. Therefore, they don't form bonds, so their valency is 0. Now, if you have your data booklet handy, I advise flipping through to page 6. You're going to need it for today's activity. And above each group above each group, I would copy in the valency of each group as shown here. Okay, so now that we know the valency of elements, so now that we know how to work out the valency of an element, we are going to run through the rules for using that information to get a formula. And the rules are shown on screen. It's symbol, valency, swap, divide, and then you arrive at your formula. I will demonstrate now. So, say we had the compound carbon oxide. The very first thing that you would do is at the side write down SVSDF, and I promise you it will keep you right. So carbon oxide. The symbols for each of these So carbon oxide. We start with the symbols. The symbol for carbon is C. The symbol for oxygen is O. Now carbon is in group 4 of the periodic table, and we know that that means it has a valency of 4. Oxygen is in group 6. It has a valency of 2. What we do then is we swap these valencies over. So the 4 moves to underneath the oxygen and the 2 moves underneath the carbon. We then look at these numbers and see if we can divide them to make them any smaller. Now 4 can be divided by 2 to give 2, and 2 can divide by itself to give 1. Now, just to very quickly remind you of something that's been said before, 1 is not included in formula. So, our formula then is C, O, and 2. Let's do some more examples. Sodium chloride. Sodium has the symbol Na, chlorine has the symbol Cl. The valency of chlorine is 1, as it is in group 1, and chlorine also has a valency of 1, as it is in group 7. We then swap these valencies over, 1 and 1. Since there is no way to make these numbers any smaller, we keep it as 1 and 1. And our formula then would be NaCl. What about then magnesium fluoride? So magnesium has the symbol Mg. Fluorine has the symbol F. Magnesium is in group 2 of the periodic table, its valency is 2. Fluorine is in group 7, its valency is 1. We are then going to swap our valencies around, like so. We cannot make these numbers any smaller, so they remain as 1 and 2. And that gives us the formula MgF2. So now that you have seen examples of how to do that, I'm going to ask you guys to use SVSDF to work out the formula for compounds A to T. Now these are on a work card that can be found via the link in your virtual classroom or under the assignments tab. Your answers should be uploaded to the assignment when you are done, and you can upload them as images of pictures from your jotter, or you can write your answers in Microsoft Word. Now remember, when you are typing these out, you should use subscript for writing the numbers in. They should be smaller than your symbols. But when you are done, your answers should be uploaded to the 2 element formula assignment, and I will get that back to you as soon as possible. What I advise you to do is pause the video here, have a go at that task, come back and we'll do some more examples and you can see if you're on the right track. So aluminium oxide. So one of the compounds on the work card was aluminium oxide. You had to work out its formula. The symbol for aluminium is Al and the symbol for oxygen is O. Now aluminium is in group 3 of the periodic table, and that means its valency is 3. Oxygen is in group 6, its valency is 2. If we swap these valencies over, as we have done in the past, our 2 comes here and our 3 goes down here. These numbers cannot be made any smaller by dividing. Therefore, it remains 2 and 3. Our formula then will be Al2O3. Another example that you would have come up against was calcium chloride. Calcium has a symbol Ca. It's in group 2 of the periodic table, so its valency is 2. We've previously met chlorine with the symbol Cl, and being in group 7, its valency is 1. As usual, we are going to swap these valencies over. 1's here, 2 under here. Once more, we cannot make these numbers any smaller, so it remains 1 and 2, and our formula is CaCl2. And for our final example, we have magnesium nitrate. Magnesium is in group 2. It has the symbol Mg, and because it's in group 2, its valency is 2. Nitrogen has the symbol N, and in group 5, it has the valency 3. We are going to swap the valencies over. So 3 is here, 2 here. And since these cannot be made any smaller by dividing by each other, it remains 3 and 2. So our formula then is Mg3N2. So well done on making it to the end of another lesson, guys. If you have any questions about anything that we've covered today, please get in touch via email either to myself or to your own class teacher. And if you're having any issues with the work card for this lesson, just let us know and we will do our best to help you out. I hope you guys are all having a lovely week. Take care of yourselves and I will see you all in the next one. Bye guys.